Hi everyone. In today's challenge, we have this problem swap nodes in pair, and the problem number is 24. Alright, guys. So first of all, we are going to understand this problem clearly. We are going to see what this problem say. After that, we are going to move to the logic part. We are going to see the brute force approach, optimize approach, and after that, we are going to jump to the implementation part. We are going to implement our logic in C++, Java, and Python programming language. Fine, guys. Now let's see what this problem says. Right. So the problem says, given a linked list, swap every two adjacent nodes and return its head. So basically problem says we are given the linked list and we have to swap every two adjacent node and return its head. So let's draw a linked list. In example one we have this like 1, 2, 3, and 4, right? Okay, now what are the adjacent? First of all, adjacent means nothing but a neighbor. So here if you see one adjacent is nothing but 2, right? And third adjacent is nothing but 4. It's 2 as well, but it told swap every two adjacent node. So now what we can do, guys, we can say the resultant linked list will be look like 2 and 1. We have swap 1 to 2. It will look like 2 and 1. And we have swap 3 and 4, which will look like 4 to 3, right? And we have to map them like this. So this is our final linked list, we can say. I hope you are getting it. We have to just swap every two adjacent node. And after that, we have to return that particular linked list. So basically, this is just one line of problem. After that, they have told you must solve the problem without modifying the value in the list node. That is only node themselves may be changed. So basically they have told them like this is a node, right? Let's say node, this is node 1 and this is node 2, right? What does it mean that we can't swap their value? Like we can't say node 1 dot value and node 2 dot value should be swapped, right? Let me write a node 2 dot value should swap, right? What we can do, we can say node 1, let me write a node 1 common node 2, they should swap, right? They can swap but their value should not be swapped, because if they value swap, the main origin we can say they pointer, or we can say node will remain same, right? So the circle will remain same, just one, instead of one it will come two, instead of two it will come one. So they don't want like this. I hope this is getting right. So I hope now you are clear with the problem. Now let's move to the logic part, what this logic say. So basically let me remove all these things, and now let me write a logic, right? So logic is going to be really simple, but before that we have to come to the brute force approach, right? I really want you to think about can you solve this particular problem. Doesn't matter what time complexity it's going to take, but can you solve this problem, right? So if yes, then write in the comment section yes we can solve this. Otherwise, let's see this. First of all, let's see the brute force approach, right? So what I'm getting in my mind, that brute force approach will be just using the array and swap the adjacent index and then convert it into a linked list, right? So first of all, we are going to get this array 1 2 3 4, right? Now what we can do, we can start a loop from here from 0. I will skip the value 0, it will going to take 1. Let me show you. So what I'm going to do, I'm going to say start a loop from here for from 0 to the length of this linked list, and on every loop I'm going to take a step of 2, because I don't want to swap 2 round. I want to swap 1 with the 2, then after that 3 with the 4, right? So I can say 1 should be swapped with the 2, so I can say array of I should be swapped with array of I plus 1, right? And this will only be done when I plus 1 should be less than n. So this is the brute force approach. Once after swapping, I can again convert this into a linked list, and I can return that particular linked list, right? This is also going to solve in a big of n. So the time complexity will be big of n only if it see in term of asymptotically. But if it is it is going to take a big of n space complexity as well, right? We have seen we have created an array, and that is not a right way, right? When we can solve in big of one space complexity, why we need to take a big of n, right? So now guys, let's see what is the optimized approach. So for optimized approach, we're going to use a recursion. Yeah, it's going to take us some we can say heap memory, right? So we're going to use a recursion. So how we can use a recursion? Let me take a first of all a linked list 1 2 3 4, and here let me take it a little bigger so that you can understand clearly. So I've taken a linked list of 6 node, and we have to swap, right, this one and this one. So how we can do this? See, every time we need to take just two elements, right? So we can think like this, we can divide into this part. Can we do this? Yes, we can do this. So first of all, I was having a full linked list, so I have divided into two parts, and I have taken 1 and 2. So let me write here 1 and 2. I have taken 1 and 2, right? Now what I can do, I can swap this, right? Easily I can swap this. I can say this should be uh, equal to 2 comma 1. After swapping, it will look like this, right? And same I can do like with this. So this will be look like 4 and 3. So let me take a blue color only, and this will also look like 6 and 5. And how it gonna look like, I know you are not getting this thing. So basically what I'm going to do is I'm gonna say 1 and 2. Once I let me tell you in a brief. If I have this linked list 3 and 4 and 5 and 6, right? So what I can do, I can say okay, my current node, let's say head pointing to 1, right? So what I can say current, my which is the current node, it should be equal to head of next, which is nothing but 2, right? And previous node should be equal to head. So now what you can see, current is having nothing but, let me take a color. Current is having nothing but 2 and previous is having nothing but 1. Now we have this two node different, so we want to make it like 2 into 1. 2 should point to 1, right? So we can say current of next should be equal to previous. I hope you are getting this. By this we have make a linked list 2 which is pointing to 1, right? So now we have this 2 into 1, right? Once we are done with this, we are going to say, okay, we have solved this particular part. Now let's solve this particular part, the rest of the part. So let me scroll it a little above. So now how we can solve this particular part? We can say, okay, now we have this 2 and 1. So let me make a resultant link list which is nothing but 2 and 1. Now I can say, okay, fine. Now you have to call this function again. And with here was head was 1. Now you have to call this function again. Here head will be nothing but current of next, which is nothing but current was 2. So 2 of next is 3. So now my new function will have this particular thing 3, 4, 5, 6 only, right? And here again my head is here. So I can again repeat this particular part. We can say current of head is current should be equal to head of next, and previous should be equal to head. So current is nothing but we can say current is nothing but 4 this time, and previous is 3 this time. And now we can say current of next should be equal to previous, and which is nothing but we can say 4 is pointing to 3 here, right? So we have solved this particular part as well. Now let's move to, let's pass into next function by giving argument current of next. So now in the next linked list we're going to have 5 and 6, where the current is going to be nothing but this one, right? And we are going to again do the same step. We are going to pass the next time, which is going to be null node. So we are going to have a base condition, that is if our head is at null or head of next is n null, then we can return our head, right? So if it is null, we are going to return null. And now guys, you have been thinking like we have make this 2 and 1, right? So we have make this 2 and 1, we have make this 4 and 3, we have make this 6 and 5, right? But these are different, right? How we can map this? How we can say 1 should be point to 4 and 3 should point to 6, right? So this is the issue, right? We are having. So how we can solve this particular thing? See guys, once we are calling the next function, we know that 1 should be point to the next thing, right? Whatever the return by the next function. So 1 is pointing to the previous. So we can say every time, whenever you're calling this function, whatever it's going to return should be stored in the previous of next. So this was here. If I go in little brief, then we have made the first time 2 and 1, right? And we have called the next function with this 3, 4, 5 linked list, right? Which is where 3 was the head. So this function was going to return what? This function is going to return something, but before that, this function also going to call and 3 and 4. So let me call a new function which is going to be 5 and 6, right? This is going to call this one where 5 is head, fine, and this function is going to call null, fine. So now we can say this is going to return 2 and 1 because this was the function 1, 2, 3, 4, 5 and 6. So this was the main linked list, and this has returned 2 and 1, means this has converted 1 and 2 into 2 and 1, and after that call this function 3, 4, 5, 6. This has converted 4 into 3 and call the function 5 to 6. This has converted 6 to 5, right? Now think about this. Here what was the previous? Previous was 1. So we can say previous of next will be whatever the function is going to return by this. And here previous was 3. 3 next will be whatever the function written by this. And here with the previous is we can say 5. So whatever the function written by this is gonna like this, right? So can you see 2 1? This is gonna return null, right? So we can say 6 5 and null. And this is 4 comma 3 is gonna return by this whole thing. So we can say 4 comma 3. Let me make it bigger. Or let me scroll it up. Right? So this is gonna say 4 and 3, right? Fine. And here we can say 2 and 1, right? So 2 and 1, the 1 is going to return whatever the return by this whole part, which is nothing but 4 3 6 5. So we can say 2 1 4 3 6 5 null is going to be our resultant linked list. So this is how we can solve using a recursion. I hope now you are getting this. So this was the logic. Basically I want to just tell you that we can use a recursion. Here we can use little bit current or previous issues. We can create a previous node, we can create a current node, and we can pass into the new function by just removing the first two elements. And basically this was the easy approach. If you will think about a little bit, if I summarize this particular part, we can say 1 and 2 was there, We have swapped them and we have called the same function again with rest of the part. And then also we have took the first two number, swap them, and we have called the same function for the rest of the part. Again we have took the two numbers and call the same function for next two part. So guys, now let's see the code part. Let's see the implementation part, how we can implement our logic, this logic, right? You will have a better idea if you will see the code part. And first of all, let's try to implement by yourself. If you could able to implement this logic by yourself, then definitely very well and good. But if you could not, then let's see the code, right? So let's move to the code part and just give me a second. I think my internet got. Let me see the, yeah, internet is not there. Okay, let me see what is there. Sorry for this, guys. I feel now internet will be there, right? Internet is there. Okay. Okay. Now what we can do, we can use a first of all Python programming language for implementation. So basically what I want to do is here, I want to say the first node, right? If a base condition will be if head and if head is null. So if we can say if head is equal to none, if it is null, so we can directly say if node head, and if head of next is null, right? If head of next is none, then we can simply return head, right? So this is the base condition because we need at least two elements to swap them, right? Now once we done this thing, we are going to use a logic part. Now what we can say current, first of all make your current node which is going to be head of next, because we are sure that now head of next exists, right? And the previous is equal to head. Now we are going to swap them, so we can say what we can say, we can say current of next should be equal to previous. I hope this makes sense. Now previous of next should be nothing but we are going to call the same function swap pairs, and we have to use a self dot swap pairs, and here we can pass a current of next, right? And once this is done, we are going to return our current. So let's try to run this code. This is a simple code and just use a 6 line, right? I guess 2, 4, and 6, only 6 line. And let's see whether it's giving an error because we are not doing something, right? Let me see what we have done. Not head, it should be O, right? Now let's see. Still it's giving an error which is self.swap pair head. Head is going to be nothing but current of next, and this should be not giving an error, right? If not head or head dot next is null, so we can simply return head, right? Fine. And the current should be the head of next, and previous should be our head, and current of next should be the previous. All right, so we have make here mistake, right? I hope you get it. So basically what was the mistake here, we have make current of head, current is equal to head of next, so current was 0.2 and 2 of next should be the 1, right? We have make it a 1, but again we are calling the same 1 again because we are passing a current of next, so we have to store somewhere. So we can say new current should be, or new head should be current of next before making a current of next to previous. So now here we can pass a new head. Now let's run this code. Okay, you can see all the test cases are passed, right? So let's try to submit this code as well, and it got submitted, right? So we have solved this particular problem using a Python. Now let's move to the next programming language, that is nothing but Java. So what we are going to do, we are going to say first of all if a head is null or head of next is null, any of thing is null, we can return simply head, right? We need at least two element. Now once this is done, let me do this like, now once this is done, what we are going to do, we are going to say list node of current should be equal to head of next, head of next, and list node of previous should be equal to head, so we can say head, and we can say current should be equal to previous, current of next should be equal to previous. But before that, what we have to do, we have to store our new node or new head, right? So we can say list node of new head should be equal to current of next. Let me write it, right? Now once this is done, we are going to call the same function with the rest of the parts. So we are going to say we can say previous of next, right? So previous is the last node which we need to point to the next function, so which will be pointing to the next function like this swap pairs, and here we can pass a current node current new head, right? Now once this is done, we are going to return our current. Now let's run this code and see whether it's working fine or not. I don't really want to get an error in Java programming language, right? You can see all the test cases are passed. So now let's try to submit this code as well, and hopefully I think it will get submitted, right? Yeah, it also got submitted. Now let's move to the next programming language, that is nothing but Java, sorry, C++, which is the last programming language in this video. So, okay, now what we are going to do, we are going to say if head is equal to null or head of next, we have to use this thing, next is equal to null. So we can say just simply return what head. But if it's not the case, then you have to say list node of current should be equal to head of next, and list node of previous, let me write a list node of previous should be equal to, which is equal to head. Now we have to say current should be, current next should be previous, and before that we have to make a new head, right? So let me say list node of new head should be equal to our head, not head, current of next, right? Current of next. Now we can call the same function, we can say previous of next should be equal to, let me write a next should be equal to swap pairs, and here I can pass new head, and we can return current. Now let's run this code, because I believe I have done almost right? Okay, you can see that all the test cases are passed. So let's try to submit this code as well and see the result. And you can see guys, this also got submitted, right? So we have solved with the C++, Java and Python programming language. Now guys, if you learn something new in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.